Hello everyone, welcome to another video of Cloud Deep Dive. In today's video, we will talk about a new feature launched by AWS for their AGA service called custom routing. So what is AGA? AGA is a networking service that improves your internet user performance and availability by using AWS global network infrastructure. So what does that mean? In your normal infrastructure, you have your application running maybe in some one of the region. What happened that when you try to connect to that application via the internet, your packets or your traffic is gonna go from your computer to your local ISP. From there it's gonna hop on from different ISPs till the time it reaches to the particular region where your application is launched. While going through all those ISPs, there will be a lot of latency will be added to your traffic, and there may happen that there will be some packet loss. But with EGA service, what will happen, how it will improve that latency and reduce the packet loss for your traffic is when it leaves your computer, it goes to local ISP. From there, it goes to a edge location of AWS. After that, the whole infrastructure, the whole traffic is gonna go on AWS global infrastructure. It won't go through the internet. It's a private infrastructure led by AWS, and it will be traveling on that. So that helps you to improve your latency and improve on your packet loss as well. So till now there was only one kind of AGA, standard AGA, and it solved many use cases where low latency is required, or for the DR purposes, or protecting your application against DDoS attack with by using AWS Shield. But standard AGA was not able to assign multiple users to the same server. And when I say that, like for your gaming application, you might require that multiple uh, players should be logged in or should be tied up to a particular server. So AGA was not able to, standard AGA was not able to give you that capability that multiple users can be routed or will always be assigned to a same server. So custom routing is launched to solve that problem, and in today's video we'll learn that how routing will work and how it will solve that particular use case. So till now, users who want to assign their multiple users to particular server, what they do, they develop their application in such a way, or they write the custom code in their application where they will route multiple users to the same instance on a particular port. So they have to kind of do lot of development at their end to do all this mapping. Like in this case, that these two users will be routed via the internet, and they will be connecting to the instance, say on some port 80. So this particular user will be connecting to instance C. So this all logic that which user will go to which instance is you have to do in your application. You have to write all the logic. So let's see how AGA solves that problem. So if we take the same example of what AGA will do, that AGA will connect do one-to-one mapping. When I say one-to-one mapping, what's going to happen that when you create a AGA, the custom routing, it asks you to give the port numbers, and there's a calculation associated with the port number. I'll show you. And suppose you have these 4 instances running in your subnet, and you say that you open 8 ports from 80 to 87. Okay, so what AGA will do, the port 80 of it will listen, or any traffic coming on the AG IP address for port 80 will be mapped to private IP of instance, say port 80. Port 81 of AGA, so any traffic coming to the IP address of AG on port 81 will be mapped to instance A IP address in port 81. Similarly, port 82 will be mapped to the instance B IP address port 80, and port 83 will be mapped to instance B port 81, instance B IP address port 81. So it will be kind of one-to-one mapping. Each port of AGA listener will be mapped to IP plus IP address plus port of this instance. So like in this table, I'm showing that, like, suppose port 82 will be mapped to the instance A port 80, port 83 of AGA will be mapped to instance A port 81, and so on. And the calculation I was talking about is like, you need to find, like, if suppose your subnet is having /28, it will give you 16 IP addresses. So number of IP in a subnet, so like in this example 16, multiply by number of destination port. When I say number of destination ports is on which port your instances will be listening. Suppose they will be listening on port 80 and 81, so there are two ports. So number of IP address multiplied by 2 is 32. If you are listening on 5 ports, suppose on your instances, then you require 80 ports. And I'll show you in the demo as well that how these ports we need to configure. So this is the basic thing you need to remember, that when assigning or when creating the AGA, the number of ports is equal to number of IP addresses in your subnet multiply number of ports on which you're gonna listen. Another thing about the custom AGA is custom routing AGA is like in the standard AGA you used to have endpoint can be your ALB or your EC2 or your EAP, but in this the only endpoint you can configure is your subnet. So you will add a subnet as your endpoint, and all the IP address with that subnet will be mapped to the IP address and the port number of the AGA. So that's one of the difference between standard and the custom. Another thing is like in standard AGA used to do the health check. So if there is any instance or any LB is not healthy, it will it used to kind of used to fall you back towards the backup or another region wherever whatever endpoint you have configured. But in custom routing it does not do any health check. It won't help you, or it won't route your traffic to some other endpoint. So whatever that, because there is a one-to-one mapping between your AG IP address plus port to the instance IP plus port. Another thing on the standard AGA that used to you can configure multiple endpoints, and based on the latency it used to route your traffic to a particular endpoint wherever the lowest latency it will get. But in custom routing it will map to the same instance, doesn't matter what the latency is. Even though the AGA latency will be less, but it won't move your traffic to another instance because it is a one-to-one mapping. So the application saying that I want to go to the particular instance, so it will take you to the particular instance only. So that's all about AGA, guys, and let's do the demo and see that how you can set it up and how it works in action. Okay guys, I have logged it into my account and we'll go to global Accelerator page. So one thing I want to tell you that this AGA will be created only in US West 2. Doesn't matter if suppose I go to US East 1, and if I try to go to AGA, it will take me back to the US West 2 region only. So you can create only in this region, you cannot create in any other region. Okay, so let's see how you can create the AGA. But before that, I just want you to do, I did some setup. So what I did, I created a new subnet in my default VPC for /28 IPs. That's small subnet. And another thing which I did, that I created two EC2 instances in that subnet, and I just kind of created a sample HTML page. So if I go to this 228.98, so you can see hello world server 1, and for the second EC2 I just have hello world server 2. So if you see, second server is my 198.152. So both of the servers are up and running. And the third thing what I do, I just created a Cloud9 environment where we will be giving some commands to check port mapping and all those things. So to create a AGA, let's go to create AGA, and here we'll give a name. Suppose I'll give you demo 1. So like I mentioned, there are two type of AGA. One is standard and custom. So we'll be doing custom in this demo. And IP address type will be IP4. It's like it just does support IP4. It doesn't support IPv6. And if you want, you can add your tags here. Now here is the port, and what port is that? Like in the PPT, I showed you that on which port your AGA will be listening to, and I showed you the formula that to calculate how many ports you need to open. So that is like number of IP addresses that based on the subnet. So suppose I'm selecting only one subnet as endpoint, and it has /28 as a my CIDR range. So /28 will give me 16 IPs, right? So 16 multiply by number of ports, and I'll show you the number of ports, what I mean. So let's see, if I give 80 to 95, that means 16 ports. When you go to the next page, here is the port start range and the end range, and you will select the region. So region, suppose I'm saying the North Virginia one because my VPC and subnet lies in that region, and I'll give you here port 80, port 80. So what does that mean? That this AGA will get two static IPs. So any request coming on those static IPs with any port from 80 to 95. Suppose a request is coming on port 80, so it will be mapped to one of the IP address of the subnet which I'm going to provide in the next screen with port 80. So if I'm saying port 80 and 81, that means I will be requiring 32 IP at 32 ports for AGA. Means that each port will be mapped to one IP address plus one port. So one IP address of subnet plus port 80, the same IP address will also be mapped with the port 81. So that's how the calculation works. So since we are just doing for the port 80, that my backend or my EC2 instances will be listening only on port 80. So I'll just give 80. So my 16 IP address for the subnet and one port, 16 multiply 1 is 16. So my AGA will be listening only on 16 ports. So I need to open 16 ports, and I'll give protocol as TCP. One more thing, let me show you. So here, instead of giving port start and end range and protocol, and then suppose you want to open two different port 80, and you can give port 85 as well. So if you want to give two different ports, you can do that as well. Second thing, you can add a different end group as well. So suppose in addition to US East 1, you want to launch your application in some other region, suppose Asia Pacific Southeast 1 as well. So you can choose that and give those port as well. But one thing to remember here, that AGA, like in the standard, you have two different endpoints in two different region, and your AGA will decide whatever has the better latency, it will route your traffic there. But in custom, it does not work that way, because there's a one-to-one mapping between the IP address port of AGA with the IP address and port of your backend instance. So that's the difference between the standard and the custom. So just keep in mind while creating the custom one. Now we'll add the endpoint. So in US East 1, whatever subnet, so you can see that endpoint type can only be subnet, while in standard you have load balancer, EC2 and other in options, but here only subnets. So we'll choose the subnet of this one, AGA subnet with /28. Now subnet traffic, we have three different options: allow all traffic, deny all traffic, and allow traffic to a specific destination socket header. What does that mean? When I select allow all traffic, that means that all my IP address within the subnet will be accepting traffic. If I say deny all traffic, that means all my IP addresses within my subnet will be denying traffic, or they won't accept any traffic. When I say allow specific traffic, or traffic for a specific destination socket, that means that I have to provide the private IP address of the instances where I want to accept traffic. So suppose in this case, my server one has the IP address this. So I take this IP address and put it here. Similarly, my port, it will be listening on port 80. Then I'll say I want to listen or want to open traffic for this particular IP on port 80. So if suppose I launch another EC2 instance in the same subnet, so my another IP will be used for that. So when I use this global AGA, it will allow traffic only on these two IPs. If I launch a third EC2 instance, it won't allow traffic to that third instance. But if I'm choosing that allow all traffic, that means you, even though you launch a new IP or new EC2 instance, traffic will be allowed to that as well. So that's the difference, that you can either choose specific IPs or you can make it open for all of them. So let's go ahead with the specific IP and we create on the create AGA. So while it's working, I've already created one which is already provisioned. So let's go, and it's so the same settings. So I selected same ports 80 to 95, and on the main screen you will get two static IPs and a little bit description about. So this is the DNS name by using which you can access your endpoints. This is the ARN number, and if I go to edit, the only thing you can choose is like you can enable or disable this AGA. So one thing to keep in mind, that these static IPs which are assigned to this AGA, they are forever. When I say forever, they will be released only when you delete the AGA. If you disable the AGA and enable it back, this IP address will still be attached to it and it won't go away. So if you're deleting this AGA and you're again creating new one, then these IP address will be changed. Next thing, let's go to the listener, and after creating as well, if you want to create a new listener, so you can create a new listener as well. You can add more ports to it, and it will go to the same screens which we did. So let's go to this listener which we created. In that we have one endpoint, US East one. If you want, you can add a separate endpoint group as well, maybe to some different region or maybe same region, different subnet. In that right now we have only one endpoint, particular subnet, but within that group as well, if you want to add a new endpoint as it, or maybe new subnet as endpoint, you can do that as well. And here you can see that endpoint traffic state is partially allowed. That means because we allowed only two IP addresses where we want to accept the traffic. When I click on this one, here it will show you that what all IP addresses are allowed. So .5 traffic is allowed, all other are denied. If I go, so everything is denied, but port 14 is allowed. So only two IPs are allowed, and you can change allow or deny here as well. So here it does not give you option to select a particular IP address. From here, either you can do allow all or deny all. So now let's see how it display the data. So if we go to my this, so first before that, let me show you how you can get the port mapping, the one which I was talking about. So we'll take this ARN number and we'll go to our Cloud9 environment. So I just kind of spin up a machine where I connect it, and so on the console it won't show anywhere that how the mapping is, with which port number, which backend port is mapped. But if you go and use this API or use this CLI command, AWS global escalator list - custom routing port mapping - escalator ARN, and then you provide the ARN number. So I give this ARN number like 4FCC0, and when I ran this command, so you can see it just is listing all the port mapping. And let's take a look. So in this it's saying that port mapping destination socket address is 172.31.96.4, which is the IP address of my one of the machine, not of the machine, basically one of the IP address from my same subnet. So 172.31.96.4. Okay, and it's this port 80 is mapped with the port 80 of my AGA port on the TCP protocol. Similarly, .5 address port 80 is mapped with my 81 port. So basically, if I give the AGA address, AGA DNS with port 81, it will map to this IP. So let's try that, because see, one of my EC2 instance backend IP is .5. So let's take this DNS name and go to HTTP. Sorry, 81. So you see hello world server 2, and if we see server 2 is 152 and 152.5. So what it's doing, that whenever I'm accessing port 81, when I'm sending request for port 81, is mapping to this IP address port 80. Similarly, let's see for the another one, the another server we have dot 14. If I go to mapping for dot 14, here you go. So it's mapped with the port 90. So the same request, if I give with the port 90, that I'm sending request from my application or from my browser, that go to port 80 of AGA, and AGA will say, okay, port 80 is mapped to which instance is mapped to this particular server, so it will show you that particular server data. So that's how AGA work. It maps basically port AGA port with your backend port. So hope you like the video. You got an idea that how AGA work and how the custom routing work in AGA. If you have any question, please feel free to post and comment, and I'll be happy to answer your question. And please like my video, share it with your friends, and we'll come back with some new feature launched by AWS. Till then, thank you so much. Bye.